Welcome all. Myself Mujibur Rahman, Assistant Professor, Automobile Engineering Department, Hindustan College of Engineering and Technology. The subject Automotive Safety. Here we are going to see a topic called Crumble Zone. So first of all, what do you mean by Crumble Zone? Crumble Zone are located in the front part of a vehicle in order to observe the impact of head-on collision through, though they may be found on other parts of the vehicle as well. According to a British Motor Insurance Repair Research Centre study of where on the vehicle impact damage occurs, 65% were front impacts and 25% are rear impacts and 5% on left and right sides respectively. This innovation was first patented by Mercedes-Benz in the early 1950s. They designed they are designed to observe the energy of an impact, especially kinetic energy, by deformation during collision. So in the image you can see a car is being divided into three categories. The first frontal part is called crumble zone, and at the rear end is also called crumble zone, and in the middle it is passenger cell. Here you can see at the crumble zones the vehicle is being designed in such a way, if a vehicle is being collided, the metal or the part which is being in the crumble zone is being crumbled so that it will absorb the energy. It will not transfer that energy, especially the kinetic energy, to the passenger cell. So in that way, it will safeguards the safety of passengers. So before going that crumble zone, we have to know about the energy equation. That is, vehicle is a dynamic body. It possesses kinetic energy. So during a collision, this kinetic energy is being transformed or transferred to the passenger cell. It may create hazardous or injuries to the passenger. So the kinetic energy of a vehicle destroyed during a collision may be expressed as E, that is energy, is equal to m minus del m into v square by 2. Basically, it is a kinetic energy equation like half mv square, where it is being slightly modified as m is nothing but total mass of a vehicle and del m is the movable mass in the vehicle, that is passenger or load, etc., and v is nothing but the velocity at which the vehicle is being traveled. So by this equation we can formulate or calculate how much amount of kinetic energy is being developed on a vehicle when it is being traveled or moved. So here you can see from the various pictures, if the mass which is located on the front of an impact, that mass will create more kinetic energy, so it will be transferred to the passenger compartment. But at the bottom you can see the engine and the load are being placed at the rear. So if a vehicle is being head-on collided, the frontal part will be crumbled so that it will not transfer the energy to the passenger cell. So in the graph you can see the figure shows that the overall design of a car can influence the distance traveled while coming to rest. The rear engine vehicle has a greater distance for two front structure. That is, when a vehicle is being collided, at the front it can be seen a lot of g-force is being generated, and when it goes to rear part the g-force will be reduced. So the g-force will be higher at the frontal part when it is being frontal collided. Only 20% of the maximum retardation is felt in the passenger compartment. This is 20 g, that is a more amount of energy is being generated when it is being impacted, which is 40 times more than the deceleration experienced during the normal braking. So if a vehicle is being experiencing a 1g force during a braking, it will be more, that is 20 times more when it is being frontal impacted. So it will obviously create lot of impacts on the passenger safety. Here, the figure shows this relation and clearly indicates the importance of the larger distance over which the force travels before the vehicle comes to rest. So in the graph you can see in the x-axis it is the speed or velocity a vehicle which is being moving. In y-axis it is the amount of g-force which is being generated. Yes, when the vehicle speed is increases, the amount of g-force generated is also high. So here we are having two comparisons, that is stationary obstacle and movable obstacle. So in movable obstacle, the g-force is comparatively less produced when compared with static obstacle. In a stationary obstacle, even if the vehicle is being traveled in less speed, the amount of g-force which is produced is high. When an accident occurs between two vehicles, deceleration involved are less than when collide with solid obstacles. The data given indicates that a long energy absorbing distance should be provided in a vehicle design, and part of the structure used for this purpose should have lower stiffness than the central section or the passenger compartment of vehicle. That is, when you are designing a crumble zone, you should provide a longer distance, and also it should, the material which you are choosing should have a lesser stiffness so that it will energy all the impact force. So in this graph, in x-axis it is a time in seconds, and in y-axis it is force which is being generated. So this graph shows it is clearly that the response time of a human being does not allow him to prepare for of an impact of this duration, and this indicates that safety belts must be used. So you can see that the impact happens and it also generates more energy in quicker time. So a proper control zone should be designed and fabricated to ensure the safety of a driver. Thank you.